Hi Year 12 Extension 2 students. This is our recurrence formula lesson number 2, and we're going to look at some harder questions, some harder algebra. Okay, so previously in the previous example, this is what we looked at. We had the recurrence formula here, that's what we had to prove. In was defined as this, and during that first part of the example, we found that I1 was 1 and I0 was pi on 2. Now, special thing to be aware of. When the recurrence formula relates in to in minus 2, it is necessary to consider separately the cases for n even and n odd when finding expressions for in. Now you'll see why that's so. So let's just start off by looking at n even, and I'm just going to do some basic numbers here. So let's just say we had I8. Well, if I use my formula here for I8, I'll get 8 minus 1 is 7 over 8 times by I6. Yep. Now, that's 7 over 8 times by, now I6, put a 6 in there, I'm going to get 5 over 6. Multiplied by I4. Okay, now what's I4? Put I4 in there. I4 will be 3 quarters times I2. Right, so you can see the pattern, stepping down by 2, so without thinking too much about the formula, right, you can see what's happening here, okay? These are jumping by 2's, alright? And these are jumping by 2's as well, so you're going to get 1 over, 1 over 2 there, yep, times by I. Now these are stepping down by 2's as well, so I0, alright? Now I0 we worked out to be pi on 2, so in actual fact you get 7 over 8 times 5 over 6 times 3 quarters times a half times pi on 2. Okay, that's for I8. Now, we want to consider what's happening to IN. Okay, so let's look at that. I'm just going to rub this out to create extra room because the working out's quite long. But let's have a look at IN. Alright, so just rubbing this out. You can pause the video and copy this down. Okay, so IN, let's have a look. IN, alright, so we're going to have n minus 1 on n. Right, now the next one is stepping down by 2, isn't it? Okay, they're both stepping down by 2. If you look back at what you wrote down, stepping down by 2, and then stepping down by 2, stepping down by 2. That goes all the way to 3 quarters multiplied by a half multiplied by I0. Okay, that's for IN. Now, we're going to do something to that expression, and we're going to say, but I0 equals pi on 2. So, what we're going to do is write out the expression again. I'm going to leave a little bit of space, just like you did up there, to write some things down. So I'm just going to copy this down again, and hopefully I've left enough room. 3 quarters times a half times pi on 2 on the end. Okay, pi on 2 there. Alright, now, it kind of looks like a factorial, doesn't it? So let's see if we can create a factorial expression. The way we're going to do that is, I'm just going to put brackets there. If I put an n there and an n there, I can do that, because that's just 1. And, which I'm going to, okay, put the times sign there, that's better. Now, in between, I really would like to have an n minus 2. Okay? That means I must also do the same thing for that. over here, I'm going to rub this out, I really would like an n minus 4 in there. Okay, and then n minus 4 there. Okay, and that keeps going, doesn't it? So, what about after this one? So we've got 3/4 times a half times pi on 2, so I'll just write that a bit longer. Times half times pi on 2. Okay, so I want the factorial to continue. So 2 over 2. Right? And I've got now, if I look at the top terms there, I've got n factorial. Just write this a bit closer. Okay, so I've got n factorial across the top. Alright? So let's see if we can simplify that a little bit. So, okay, alright, so actually I'm just going to write this out again. N minus 1, n minus 2, n minus 3, n minus 4, n minus 5. So I'm just going to put the factorial in there. You'll see why I'm doing this. All over. Now, you'll see I've got repeated terms here. They're all squared. So I'm going to have n outside of n minus 2, n minus 4. And that goes all the way down to 4 times 2. Alright, and I'm going to put that in brackets. That's squared. Okay, so because I've got, think about it, I've got 2 2's and I have 2 4's, there'll be a 4 there. And on the end of that I've got multiplied by, oh, sorry. And on the end of that I've got multiplied by pi on 2. I'll stick that on the end. Okay. Alright, so you'll see there's a reason why I wrote this out again, because we've got to count the number of terms. Now, the denominator inside the brackets, let's write this down. The denominator inside the brackets the expression inside the brackets of the denominator. That's what I should say. The expression inside the brackets of the denominator as half the number of terms as a numerator. Hope you can see the red. About this is, let's look at some numbers. Let's just say if n was 6, what would you have? You'd have 6 times 5 times 4 times 3 times 2, okay, times 1, 6 terms. And then in brackets you have 6 times 4 times 2 squared, okay? Now, in that situation, you've got 6 terms there and you've got 3 terms there, so 3 half of 6. So here, has inside the brackets has half the number of terms as the numerator. Okay? So, and the other way of looking at that is you've got from 1 to n, you've got n terms there. Okay? So if you're going to take out half of those terms, right? Half of those terms, obviously that means you've got half the terms. So there's 2 ways of thinking about it. You can deduce it from looking at that big expression, or you can break it down to a smaller case, and by looking at the smaller case you can deduce what the our pattern is. Now that's going to be important because, okay, so therefore my denominator equals, now this is quite a long expression, I don't know if I can fit it in here. Okay, so what do we have? We've got little equal sign there, square brackets. We have 2 n on 2 times 2 outside of n on 2 minus 1. Let's just see what I'm doing here. I'm taking out 2 as a common factor. So I'll just get rid of, I'll put 2 here and 2 there. So if you look at the first bit, n is 2 times n on 2. n minus 2 is 2 times n on 2 minus 1. Okay? And the next one will be 2 brackets. Alright, we're going to have n on 2, and that'll be minus 2. Okay? Now, can I squeeze it in? I think I can. Do my best. 2. And then the next one will be n on 2 minus 3. That should go all the way down to dot, 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 dot. Okay, now we're going to have 4. Okay, so for the 4 there, I've got the 4. Now I want to have the 2 there as well, which means I've got to put the 2 there. Okay? And then over here, I've got the 2 here times, and then I want to put I want to have a common factor of 2 there as well. That's all good. Okay. Now, that is all squared. Okay? So what I've done is I've taken out 2 as a common factor for the expression inside the brackets, and it's still squared. So I'm just looking at the denominator only here. Alright? Now, let's have a look at that. N on 2 terms only. Think about it, because if there's n terms there, and here's half the number of terms inside the brackets, then I've got n on 2 terms. Okay? So, n on 2. Alright, so I've got n on 2 terms here. Now, that means we can finally write an expression for in. Okay, now, that's n factorial for the numerator. That's nice and easy. Okay, and for the denominator, it's a little bit harder. Now, look at all the 2's there, all the red 2's. How many red 2's do I have? Right, well, it'll be 2 to the n on 2, because if there's n on 2 terms, there'll be n on 2 2's. So 2 to the n on 2. And the other interesting thing about this is, look, n on 2 minus 1, n on 2 minus 2, n on 2 minus 3. That is n on 2 factorial. Now, you might be saying, how can you do factorial for a fraction? Don't forget, n is even, isn't it? So if n is even, it's divisible by 2, so that's going to be the whole number. So that is a factorial expression. Look, it's stepping down by 1's. That is a factorial expression. Now don't forget this guy on the end here. You've got multiplied by pi on 2. And the other thing not to forget is that that expression inside the square brackets is this. And don't forget that is all squared. Okay? So we can tidy that up a little bit. You can have pi n factorial on the top, and then if you're squaring this, don't forget your rules of addition for the indices and multiplication. So best way to look at that is, okay, I've done it in 2 steps. So n minus 2 factorial all squared. 2 to the n on 2 squared. That's just going to be 2 to the n. And actually, I'll get rid of that pi for the time being. I'll put that in at the end. That's times by pi on 2. Now 2 times 2 to the n is 2 to the n plus 1. So your final answer is pi n factorial on n on 2 brackets factorial all squared, right? And then 2 to the n plus 1. Okay, that is correct. All right, so that's your expression for in when n is even. Okay? Right, so it's worth maybe having a go at that yourself. Once you've copied all of that down, try and do all the algebra, make sure you understand where each part comes from. Now, I've tried to break it down as much as possible so you can see all the 2's here. How many 2's are there? There's 2 to the n on 2. I've tried to put as much steps in there without making it too much working out. So I like this question. I think it's quite neat how we're forcing the factorial in there. That's quite good. So, alright, now the next thing we've got to consider, we've done n even. What about when n is odd? Alright, so copy that down and let's look at n is odd. I'm just going to rub this out. Okay, so for n odd. Alright, so let's rub that out. Let's put n odd. Okay, so for n odd, I think I lost my blue text up. Alright. Now, for n odd, well, let's have a look. Let's just say I had I7. I7 is 7 minus 1, which is 6, over 7 times by I5. Now, that's 6 over 7 times by what's I5? Well, it's going to be 4 over 5 times I3. That's 6 over 7 times 4 over 5 times that was I3. I3 is 3 minus 1 is 2, 2 over 3, and then times by I1. Now remember, we said I1 was 1, didn't we? Yep. So you can see the pattern here, starting with these are stepping down by 2's, these are stepping down by 2's, and I1 is 1. Alright, so 6 over 7, 4 over 5, 2 over 3 times by 1. Okay, I'm just going to write this out because I need the room. So you can copy that down. Alright, so let's have a look at n odd. Right. Now, for n odd, In will be, alright, n minus 1 on n. Let's start off. And remember it's stepping down by 2's. So n minus 3 on n minus 2, n minus 5 on n minus 4. Same as before, really. And then we've got 4 over 5 times 2 over 3 times 1 at the end. Yeah? So 4 over 5 times 2 over 3 times 1. Alright. Now, what are we going to do from there? Okay, so we're going to try and force another factorial in there. You can see here the factorial will be on the bottom this time. So I'm going to write down n minus 1 on n. And then I'm going to put the factorial in there. Okay, now I've got to put an n minus 1 in there. So let's just do n minus 1 over n minus 1. Alright, then n minus 3 over n minus 2. Alright, now what's between n minus 2 and n minus 4? That should be n minus 3. And I'm going to do the same thing to the numerator. Okay. What's next after that? I've done that. N minus 5 is next. And then n minus 4. right? Da da da. 4 over 5. Now what becomes between these two? Well, I'm going to have to put in, right? That should be a 4, shouldn't it? Right? Then 2 over 3. Well, what comes after that? And the next one down should be times 2 over 2. And then the last one, the 1, well, that's just 1 over 1, isn't it? Okay, let me rub this out. Okay. Rightio. Alright, so now we've got the factorial in there. And okay, so we are going to write down on the bottom and factorial. Okay, now on the top, you'll notice that we have pairs of terms which are squared. So we're going to go n minus 1, n minus 3, n minus 5, all the way down to, right, 4 and 2, don't worry about the 1, and that will be squared. Alright, so we've got 2 of each of those terms in the numerator. Alright, how are we looking so far? Let's look at the numerator. So I'm just going to look at the numerator now. So for the numerator, because we're quite happy with the denominator there, let's have a look at the numerator. Okay, now we're going to take out, so square brackets, 2, bracket, n on 2 minus a half. Alright, so n minus 1 is 2 brackets, I'm taking out 2 as a common factor. Then next will be times by 2 brackets, that's n on 2 again, minus 3 on 2, keep going, and then times 2 brackets, n on 2 minus 5 on 2, right, keep going, and you're going to have 2, 4 by 2 on the end, yeah, okay, that'll do. And 4 by 2, okay, squared. Alright. Now, I guess we could, take out 4 for each term, 2 for each term. I could write that as 2 by 2. But we'll keep it as 4. We'll keep it as 4 times 2. That's okay. Alright. Now, next part. Oh yeah, how many terms? Right, now how many terms are here? How many terms? Alright. Well, consider this. Actually, I'll do it over here. So, a little arrow, I7. What would I7 look like? I7 would be 6 times 4 times 2, all squared, divided by 7 factorial. Alright? This is for n odd, don't forget. Now, there's 3 terms there. Right, and obviously 7 factorial will be 7 terms, wouldn't it? So 7 terms there and 3 terms inside the brackets. So you can think of this as n, so if that's n, this is n minus 1 divided by 2, isn't it? So 7 terms, 3 terms, so n minus 1 divided by 2. So the numerator has n minus 1 divided by 2 terms. Alright. So, what we can say that therefore the numerator is equal to, now let's think about how many 2's do we have? Okay, how many 2's? Alright, so there's another 2 there as well. Well, altogether, how many terms do I have? I've got this, so I'm going to have 2 to the n minus 1 on 2 terms, aren't I? Oh, sorry, 2 to the n minus 1 on 2, yeah? Because I've got n minus 1 on 2 2's. Now, what about this guy down here? You can see that, what's the difference between a half and 1 1/2? It's 1, isn't it? So this is stepping down by 1. So this is actually n on 2 minus a half, n on 2 minus a half factorial. Because remember, the factorial is stepping down by 1. And don't forget we've got the squared there as well. So squared there. Alright? That's looking good. So what we can now take out the 2 out of those brackets, can't we? Combine with that power. So that's going to be n on 2 minus a half factorial multiplied by 2 to the n minus 1. That's all good. And then we can take out a half outside of the brackets here. So a half will be, that's n minus 1 there. And that will be factorial and 2 to the n minus 1. Yep, and we've got to carry through the squared part, don't we? So that should be still squared, and this part here. Change that. So that should be n, square brackets, a half, outside of n minus 1. There's my factorial gone. There we go. Squared. What we've got there. Yep. And all good so far. Got the squared. Okay. So now we can finish what in is. In. Okay, which is back here. Here's my in. Okay, so I've got a half n minus 1 factorial. Okay, and it'll be all squared, and then that's divided by n factorial, and then times by 2 to the n minus 1. Okay, that's it. It's all good. Okay, let's just double check that. Now, just realised mine. Okay, so the brackets, that factorial there, I've got to keep that in there. So when I'm doing this part, alright, that factorial should be, that's a half outside of n minus 1, another bracket, and that's factorial, that's what I needed. And ditto here, half outside of n minus 1, that's factorial. That's better, yeah. Okay, that factorial applies to the whole expression there, so you need to keep those brackets in. Quite complicated, but you can see how we've got different expressions for the n even and n odd. Okay, so that's all good, all squared and factorial too. Okay. Interesting question. I'll stop the video there and then I'll do another example for you on a different video. Alright, make sure all of that's copied down. And we'll see you next example.